Hey everyone, I wanted to take a few moments and go over a couple of questions um, from the homework on chapters 4 and 5. I try to pick out a couple of difficult ones just to kind of help you through some more complex problems. And this is a good one right here. It's number 3 on chapter 4, and it talks about understanding the changes in equilibrium price and quantity. And what it talks about is that you are an analyst for an oil refinery, and you're kind of responsible for estimating the equilibrium price and quantity of home heating oil. And you have to consider a lot of factors when you're looking at this. There's a couple of things that can kind of impact the demand for heating oil, which is household income, the price of an oil furnace, which is a kind of a complementary good, the price of natural gas, which is a substitute good. And you have to kind of use these with this little calculator down here to answer the questions that it's asking you as an analyst. So this information right here is all pre-populated. So is this supply and demand graph. And when you change inputs on this little calculator here, it will adjust your graph for you. So I kind of had to learn some lessons doing this the first time, just on how to use the calculator properly, and I kind of wanted to go through that with you real quick. So the first question it asks us is, it says, or it gives us some information first. It says the initial price of natural gas is $10 per 1,000 cubic feet. The price of oil furnace is $2,000. The average household income is $40,000, and the cost of crude oil is $25 per barrel. And the cost of refining oil is $15 per barrel of heating oil, which is the industry you work in. All this information that they just stated is right here in this little box. Okay, and we can adjust it as needed. But this is kind of our starting point. The first question it asks us is, what is the current equilibrium quantity in this market, uh, and what is the price? Okay, well, you can do one of two things. You can come up here and look at this graph and kind of try to figure it out how we do in class, where you kind of just um, you know take the equilibrium where the supply and demand curve intersect, and kind of come over here and see that it's a $40 price point, and I think it's 80,000 barrels per day. An easier way to actually do this, I had to learn this after the first try, was if you go up here on this calculator and just increase this to 40, okay, which is what the price gave us right here. It will do uh, the thousands of barrels for you, so it kind of makes it easier. If you notice here, it says what do I move this to 40? It dropped this to 80. So the first question is, well, the equilibrium quantity in this market is 80,000 barrels of heating oil per day at a price of $40. Okay, it made it a little easier to kind of calculate when you find the price and kind of put it in here, and it adjusts the quantity demanded for you. If you want to go in there and reset that once you're done, just click on this reset button, and it will put everything back to normal, which is what we want. And you've already answered this question. Okay. So the next part of the question says, suppose that the cost of crude oil increases from 25 to 35 for each barrel of heating oil produced. Assume that the rest of the determinants of the supply and demand for heating oil remain unchanged. Okay, what will be the new equilibrium price? Okay, so what we're going to do is we're going to change the cost of crude oil from 25 to 35. So we'll come up here and change this 25 to 35, and that should switch. Yeah, it did. It's exactly right. It adjusted our supply curve up and to the left. Okay. Um, Okay, yep, cost of crude oil. Okay, we're good. We're still good. Okay. Um, and it says, assuming that the rest of the determinants of supply and demand for heating oil remain to their initial values, the new market equilibrium will be at a price of what? Well, what we're going to want to do is come up here and um, see where our supply and demand curve intersect. Um, and the best way to do that, let's see if we can. Nope, we can't do that. But what we'll do here is, what I'm going to do is I'm going to keep moving this, okay, to where we hit where the supply and demand curve intersect, and that should give us the new price. Boom. Okay. So what I did was I just kept increasing the price of heating oil to where I was right at the point of where the new supply and old demand curve intersect. And if you notice here, I had to move my dollars per barrel all the way up to 48. Okay. So the new equilibrium price is going to be $48. Okay. And once again, When I want to go back here and reset this, which I would want to, just click on the reset button and we're good to go. Okay. So the last question is, well, it tells you reset your calculator to the initial values. It says, suppose that instead of a change, and let me go ahead and change back my crude oil price too to get us back to normal. Good. Okay. The last question is, it says, suppose that instead of a change in the cost of producing heating oil, there was an increase in the price of natural gas from $10 to $15 per 1,000 cubic feet. If the price of heating oil were to remain at the initial equilibrium price that you found in the first question, there would be a blank of heating oil, which would exert blank pressure. Okay, so what we want to do now is change the price of natural gas from $10 to $15. Someone to come up here, change that to 15. Okay, that's going to shift our demand curve out and to the right. Okay, and it wants us to know, okay, so what happened here now is our demand has increased. Okay, as you see, our demand curve has shifted out. Okay, so we want more demand than we did last week. Okay, our supply curve though has stayed the same. So that tells us something. We've increased our demand at every price point without increasing supply. So in that situation, when we want more demand than there is supply in the market, we are going to experience what's called a shortage. Okay, so we're wanting more in the market than is currently produced. And over time, what's going to happen is companies are going to realize that, and they're going to produce more product, but it's going to be a little more expensive to produce. So what we're going to see is an upward pressure on prices. Okay, so let's see how we did. Okay, we got them all right. Okay, and the key thing here is just use this little calculator to help you kind of, figure out where the actual equilibrium price is when you kind of adjust things, and remember to reset them every time that you look at this question. Good news, this is one of those things you can kind of pick and move out a little bit, and you'll get it after a couple of tries. Okay, so I'm going to X out of this one. Hopefully I don't X out of the whole program. Nope, I didn't. And now I'm going to go to chapter 5 real quick. I'm going to go to chapter 5 homework, and I'm going to do one of the bigger point ones as well. Let's do, which one did I select? Yeah, let's do number 4 on chapter 5 homework. And this is the total revenue associated with price elasticity of a product. Okay, and I think it's going to talk about a toll bridge or something. Yeah, okay, let me reset this one real quick. I tried it just to make sure I knew what was going on with each component there. Okay, so this is, we run a city bridge, and we must charge the exact same toll to all our residents. Okay, and right now we've set a price of $7 per trip. Okay, and the blue line here on this graph here kind of shows us our demand for any particular price point. Okay, and it asks us on the following graph, use the purple triangle, which is right here, to shade the area representing the total daily revenue when the toll is $7 on the graph. Notice that when you click the rectangle, the area displayed. Okay, so what I'm going to do is grab this purple, okay, and I'm going to start it at $7 over here. Okay, I'm going to have the top of it start at $7, okay, because that's our price, and I'm going to move it over to where the $7 and our blue demand line meet. Okay, and at that point, I'm going to pull this all the way down, okay, to the quantity of vehicles that kind of pay the toll per day. And what this is really is shading in is the profit area. And all this is saying is that at $7, if I follow my line over to $7 and hit the demand curve, I'm going to have 15,000 vehicles per day cross that toll bridge at the $7 price point. Okay. So the next question it asks is, hey, what if we change the price? It says your boss or advisor suggests that let's raise the toll to $8. Because they think that would bring in more revenue. To analyze this, we're going to use our green triangle or rectangle to shade the area representing the total daily revenue when the toll is $8. Okay, so once again, I'm going to grab this green little rectangle and come over here to 8, start over by 8 price point. And in this situation, because it's such a small area, at my $8 price point, the little rectangle already matches up, already hits our blue demand curve. And now I'm just going to carry this down once again, all the way down so I can see how much quantity I would sell. Okay. So once again, if I take my $8 price point over to where I hit the demand curve, that's what consumers are going to demand. We will sell, or we'll have 10,000 vehicles cross that toll bridge at that price point. Okay. So then it wants to know what the total revenue is, okay? All you need to do for total revenue is take price times quantity sold, okay? So with our $7 price point, we had a $7 price and we had 15,000 vehicles per day, okay? So if I take, I don't remember even having to math this out. On the total revenue, okay, yep. Okay, so I'm gonna take the $7 price point and times it by the quantity of vehicles that went through per day, which was 15,000. And I think my total revenue for this is 105,000, which was once again taking $7 and timesing it by 15,000 vehicles that pass per day, which is 105,000, and I just put 105 in there, okay? So we wanna see how much the total revenue at the $8 price point is as well. So I'm gonna take the $8, okay, our price point, and when we hit our demand curve and come down here, that means we sold 10,000. So I'm gonna take my $8 price point and times it by 10,000 vehicles that came across our toll bridge for the day, and that comes up to 80,000 in total revenue per day. So the question is, based on our analysis, is our advisor right or wrong? Do we make more money at the $7 price point, or we didn't make more money at the $8 price point? And clearly, we make more money at the $7 price point. So our net advisor is incorrect, okay, in suggesting that total revenue would rise if you increase toll from 7 to 8. And the reason the price goes down is because we as customers, okay, don't like the prices this high on the demand curve. We are elastic, okay? We will move off, we will take the longer route if you continue to raise prices up here, because we already feel we're paying a high price at 7. You move it up to 8, we're really unhappy, okay? So let's grade it now and see how we did. Good. Okay, we got it right, okay? So there's a couple of examples of how to do these questions, kind of some harder ones on chapters 4 and 5. I'll post this on D2L so you can take a look at it and kind of follow along when you do your own homework questions. All right, everybody, have a great day.